Okay, so let's go ahead and look at this here closely. So okay, so I'm gonna clear this, and I'll say is df, not df. So do anybody know what a mounting means? Mounting a CD drive or mounting a mounting of a drive. Okay, that's what we're gonna learn next. But before that, there is a command you should run here. It should the command is called part probe, PARTPROBE. Okay, this stands for partition probe. So what will happen is sometimes the system will not recognize the partition we created, so you have to run part probe if it doesn't show up here in LSBLK. Okay, so I'm gonna below, I'm gonna say run part probe. Part probe is what? It's nothing but a partition probe. So it's gonna go through in the system and take a look here and register any broken or unregistered partitions. Okay, now comes the fun part. So we created the partition here, right? But that doesn't mean we are able to use it. So think of this as like an open warehouse, and then we are building a room in here, right? For you to be able to build a room, you have to do some cleaning and all that thing. So you have to make it ready. So let's do this. The next step is called creating partition. Creating the file system. So file system, okay, so if you go into Windows here and if you go into Windows and if you right click on here and if you go into properties and disk sharing, okay, so oh, right here in front of my eyes it says file system here, right? It says file system is NTFS. So the file system is nothing but how the system writes the file to the disk. Okay, so let's take a look. File system in computing, file system of file control, file system controls how data is stored and retrieved. Okay, so this is a good definition. Yeah, go ahead. You got a question? Okay, so let me explain you how to create a file system here. So the definition says that how the file system, how in computing a file system or a system controls how the data is stored and retrieved. Okay, so basically how you write the data to the disk and how the data is retrieved, access. So stored is writing and retrieved is access. Okay, so now the command, what we have to do is mkfs dot ext4. Okay, so this is the file system used by actually there are two file systems used by where the Linux. One is ext4 and other one is xfs. Okay, I'll talk you about what ext4 and xfs is in a minute here, but it is the different file system how it's written and stored the data. Okay, before that, so you type mkfs dot ext4 and then you have to type the location. So which drive you want to do? You want to do SDB1, right? So where is the location for SDB1? /dev/SDB1. Okay, and then hit enter. So what happened here is it created a file system in here. Okay, so the important thing you have to notice is block size is 1024. I'm sorry, 4096. It's using a 4 kilobyte block space. It's like the tile here, tile on the floors. You have tile full of floor, right? And if you're gonna put a box in on the floor, it's gonna take up some space. Okay, so the minimum space, even if you put a box inside a room which has all the tiles here, the minimum size is gonna use is 4 KB. No matter, the minimum, it starts off with 4 KB. Okay, so let's do this. So here, if you look in here, it is automatically taking 4096 and is doing the strides, blocks, stripes, width, 0 blocks. And then this is the important thing. It is providing inodes. How many inodes is providing? On this 8 GB, the system is automatically taking or allocating 524,288 inodes. So what that means is the most you could the most files you could have on this system, on this block of 8 GB of the hard drive, is going to be this amount. So if you have like a blank files, the maximum blank files you could have is about this number here, 224,288 inodes. Okay, and the 5% is reserved, so I'm not really worried about it. In the real world scenario, the disk space is unlimited. You don't have to worry about the disk space as much, because you'll be working in a big corporation and they have a big budget for keeping the data, so you don't have to really worry about this. And first data block, it says 0. Okay, so I'm gonna skip forward here. So all this is not really that important, but it'll give you that information here. So the only other thing I would say is you need to just understand is the inodes. Okay, because earlier in the class we talked about inodes, right? So inodes, okay, it's not going past that here. Maybe I'm going to remove inode. Okay, here. So the inode. So inode is it is also referred to as how many files you could create, and it is also a table on the disk. So it is a table on the disk holding file information, and it will tell you who is the owner of the file, group the file, the type, permission, date and time. And then how do you see all the inode information? You run the stat command and it gives you good information about the specific file. Okay, good. So now don't be confused between the number of the inodes which is available and then the inode number itself. Inode number is the number assigned to the file, and the number of the inodes is how many files a system could hold. So here this 8 GB disk could hold up to 524,288 files. That's the maximum it would ever hold. Okay, I'll explain you what that is a little later here. So let's see here. I think I should copy from the top.
Can I ask a question?
Yeah, sure.
You said it could hold 524,000 files.
Mm-hmm.
But does it not depend on like how big the files are?
True. Very true.
So how could it give us a number like this many files without telling us like how big of a file?
A file could be 8 gigabyte of files. It could be, then it will use up. If you have like a single file and it's 8 gig,
right,
the whole disk is used up. Okay.
In that case, this number is false then.
No. Okay. Whoa. You're claiming Linux is. Okay, I respect your opinion. Okay, but here, what if you have a file which is only 1 KB? Okay, or 0 kilobytes. So,
okay.
So for instance, if you have like files which are 0 kilobytes, and it's not gonna take up any space, but the information is still written on the disk, right? So it's taking the inode block. So
Okay.
so the maximum number of files it could have, even if the file is 0 bytes or 0 kilobytes.
Also, it's the maximum number.
Yeah, this is the maximum number you will ever have. Okay, so this will be a very you will run into inodes issue a lot, almost every week. You're gonna have to deal with the inodes issue. I'll show you how you deal with it. Okay, so before I forget, let me copy this part here. Okay, so let me copy this information from here. So yesterday I kind of mentioned, so we have bytes. One byte is 8 bits. So any information, if you write like a 0, even if you write like a 0 on the disk, it will change into binary, and then it will have 8 digits to it. Bit byte, I think there is one more, the 4 bits. 4 bits is called nanobit or something, right? What are 4 bits called? Nimble. Okay, 4 bits is called nimble. That is usually done in scientific computing. Okay, I'm not worried about that. Nimble. 2 nimble makes it's not showing here. So 1 byte is 8 bits. 4 bits is 1 nimble. Okay, and then the kilobyte and all that here. So how is this happening here is 8 bits, so it's base 2, right? 0 and 1 is base 2, binary is base 2. Base 2, which is 0, 1 and 0. 1 stands for on, 0 stands for off. So no, not that. So if I have this here, uh-oh. So then here 1 is 1 equals to on, and 0 equals to off. Okay, so let's remember that. Let me, and so 1024 is nothing but 2 to the power of 8. Okay, 2 to the power of 8, then you will get 1024. So let's see here. 2 to the power of 8 is 256, right? Or let's see here, 8 to the power of 8. Yeah, okay, no. So 2 to the power of And 9, what is 9? 10. 2 to the power of 10 is 1024. And then 1000 megabytes would be so actually let's hold this off here. I'll come back to this when I'm gonna explain about IP address. So here I'm gonna mark it red. We'll hold this off here, but let's concentrate on this one here. So the block size here is 4 KB here, right? So if you create a 0 kilobyte of file, it's going to use 4 KB up until it hit 4 KB. Anything more than 4 KB, then it jumps to 2, then 16 and 24, so on. Okay, so this part, you are clear about this part here, right? Okay, good. So now let's move forward. So what happened here is, so far what we did is we created the file system. So the file system we created is ext4. Okay, so now what we need to do is we need to mounting the file system. That means what is mounting? We are making it ready so that we could use it. Making it ready. Making it available. Okay. For usage. So I think I have to explain you the file system first. Yeah, let's go into file system. File system structure. Linux file system. Okay, I'm not worried about that. So before that, so in Linux it started off with ext2 file system. So I'll tell you what that means. So we have file system, and the maximum disk disk size. Okay, maximum disk size. And the size of the single file. Okay, so the third column would be right, maximum disk size, and third column is single file size. Okay, and let me so there used to be file system called ext2, and we are not using it. ext2, okay, the size of the disk, the maximum size of the disk will be 32 terabytes, and the single file would be no more than 2 terabytes. Okay, and ext3, the size would be for the disk size would be 32 terabytes, and then still 2 terabytes. What is different here? The file system, how the file system defines how is the file written and retrieved. ext4, they have some improvement. Okay, the size of the disk would be 1 EB byte, and then the size of the single file, okay, would be 16 terabytes. And XFS file system, we're going to learn about ext4 and XFS in this class. Okay, the smallest the disk size, maximum disk size is 16 EB byte.
Wow.
And don't even ask me what EB byte is. I mean, it's a little confusing. And the maximum size of the file itself is 500 terabyte. Single file I'm talking about. The size of a single file is 500 terabytes here. So if you think you have a 1 terabyte hard drive and you're happy with it, so if you find a file which is 500 terabytes, you need 500 of those hard drives.
Wow.
And I've seen it because Oracle database is the one which is using the files which goes into terabytes. I'm not even kidding about it. It's
What's the size for NTFS?
NTFS? You are a Windows guy, right? Let's look at it. NTFS.
Because I know FAT32 is only 4 gigabytes.
Okay, so it's supporting 4 petabytes on 29. And the maximum theoretical limit for the individual size is 16 EB byte minus 1 KB. What does that mean? So I think it has improved. It's supporting 16 EB bytes.
Right, that's not bad. But then FAT32, I think is the biggest size is like for a single file is 4 gigabytes.
Oh, really? Right here, the FAT ext maximum, NTFS maximum, single file. Let's type in single file size. So it's touching 16 EB bytes. So that's pretty good, actually.
Yeah, not bad.
Yeah. And the maximum disk size is 56 terabytes. You know what, don't worry about going into like EB bytes and all this. You just, the most worry about is 500 megabytes and terabytes. That's it. Okay. Okay, so let's so this is what it is, and I think all this is true. So 15 terabytes for 7, Red Hat 7, right? Red Hat 7, okay? And for Red Hat 6, it's only 100 terabytes. I don't know anything about the new one, Red Hat 8. Okay, so that's the only major difference I would say. So, but I'm seeing EXFS is used almost every day. Once in a while I get to see ext4. Let's see if I could find so we have kilobyte, megabyte, so all this here. Okay, so I'm gonna just copy this. This is enough here. You're going up into terabytes. That's enough. Okay, so now, so we have the file system there, the hard drive with the partition there and getting wasted, so let's use it. So for you to be able to use the file system, you have to mount it, okay? So before that, I'm going to say create a folder, okay? mkdir, I'm going to say slash data, data, and hit enter. So now what I'm going to do is this data file is right now it's pointing on the space onto the C drive, right? The command to see the hard drives is dff and h, which are being used. So right now I created a file data in here, and if I create any files in that folder, it will be saved in anywhere on this file system. Okay, now what I'm going to do is I'm going to use that data folder to be used with the partition we created here. Okay, so how am I going to do that? Mount, MOUNT, okay, slash. What is the official name of the SDB1? dev/sdb1. And then where do you want this to be mounted to? I want it to be mounted to the data folder. Okay, and hit enter. Now if you type df-h, look closely here on the bottom here. The data folder is now being used as a window for this drive. So anything you're going to write inside data drive is going to write on, data folder is going to write on the disk dev sdb1. This is actually a partition. The disk would be sdb1. Okay, so let me break this down how this is working here. Okay, so first one is the command. So you just learned the new command. It's called mount, and this is called officially the file system. Okay, and this is called mount point. Mount point or location is said. So what is the command mount? And we have to give the file system dev/sdb1, and the mount point location is data. So you could see dff-h, or you could also type lsblk. LS stands for list, BLK stands for blocks. Okay, now in this output, you see SDB1 is being used by data. And here it's the same information, dev/SDB1, and is being used on data folder. So now, if you want to save something to that drive, all you have to do is change the directory and start saving it in the data folder, okay? Now here says we said 8 GB, right? But 8 GB, little bit is being used by the system here. Like when you go out and buy iPhone, it says 64 GB, but you're not exactly getting exact 64 GB because the operating system is being used up too. So that's what it is. Any disk, you will never have full access to the entire disk size. Okay, it will be little less than what it says. It's just dishonesty there. Okay, so the command to unmount is, so if you don't want to mount it here, you want to unmount it, right? What you could do is umount. The command is not unmount, umount, umount /data. Okay, and if you do lsblk, see, this is not mounted here, so SDB1 is not usable anymore and the data folder is gone. If you look here, SDB1 is just sitting there and getting wasted. It's not being mounted to any place. So this is official. I think officially this is what you see uh, to see the disk and mount point being used. Okay, so lsblk will bring up everything, okay, and df-h, it will show you the ones which are being used. Okay, that's all, that's the difference. So everybody with me so far, right? So I'm going to clear this and let's go ahead and mount it again. So when you're mounting it, you have to tell the source and the destination. Okay? And it has to be source and destination, you have to use it absolute path. Okay, so I mounted this diff and h. So what happened here is the file system is mounted here, but this is temporary. So everybody go ahead and restart the system. We want to see if this is going to survive the reboot. Okay, so if
I think I did something wrong.
Yeah, go ahead. Give me a team view.
Okay, give me 1 second. So last three are 188, and it's 71 F3 ZF.
Okay. SDB A1, take A out from the source.
The data has to be in capital.
Yeah, I mean it has to be exact the way if you name it capital, then you have to give it capital.
Oh, okay. Let's see what happens.
Yeah, so it seems you didn't. So did you create the file though? You have to create the folder first.
I think what I did, because before I didn't write it in capital, I just wrote the
You do ls
data.
here. I think you created in the wrong place. Do ls.
Let me try this 1 second. Let's see if this works.
Yeah, you did. You did with lowercase then.
Okay.
Now do df-h. Okay, so you see that dev sdb1 is mounted to data folder. Okay, so now what you want to do is go ahead and restart. So what this is doing is this is mounting in the memory here, so it's not mounted permanently. So when you do the restart, it will be gone. It will be unmounted automatically, because you have to make an entry into the configuration file here. Okay, let's take a look. So I restarted the system. Let me go back in there again. Okay, if I do df and h, and you see SDB1, this line is not there anymore. I don't see it. You could confirm it by lsblk. SDB1 is just sitting there, but it's not mounted here. So under mount point, you don't see anything there. That means SDB1 is getting wasted. So what you might want to do is,
So when I do the restart, I don't get that sign in screen.
no, you have to re-log in again to Putty.
Okay.
Yeah, Putty goes inactive, so you have to reactivate it.
Okay.
Okay, so we restart the system. So what is the solution? You have to make it persistent. So I'm now going to copy that whole thing. Okay, so now what we have to do is we have to make an entry into the configuration file. So it's called fs tab fs tab file system. Fs tab stands for file system something. Okay, yeah, let's look at it. Fs tab file system table. Okay, that's what it stands for. Fs tab is file system table. Okay, and it is a configuration file. Configuration file helpful during boot for mounting disks. Okay, so where is the location of the configuration file? It is in etc fs tab. Okay, in the interview, if you don't tell the interviewer where is the configuration file of this table, I don't care what you do, you will never get the job. Okay, if you don't remember this file, you will never get the job. So the file is vietc fs tab. Okay, and hit enter. And this part here, from here to here, it's starting with the pound sign. We'll talk more about this, what this pound sign means in the scripting. But from here to here, it's just the comments here. It doesn't mean anything to the operating system. But this file, this line, what is this line here? I'm going to open another window. Root Red Hat. If I do df-h, so what happens here is, you see this here /dev mapper, and this part is coming from here. Okay, and then the UUID, the boot, that file system is, this line is mounting this here, this line. And then the third one is a swap. You don't see swap in here. I'll tell you what a swap file is when we get to swap here. So what about the other ones here? The other ones that are mounted here, this information is coming from the boot process. Okay, and this part too. All this is being loaded from the boot process here. So it has a dev, run, and all this here. We'll come back to this here a little later, but let's concentrate what we have here. Now, for us to be able to automatically have this system mounted here, what we have to do is we have to open a new line and then enter the, you could give space here. If there is a space, nothing starting, doesn't matter. You have to give the name of the file system. The location. The one you have is dev / sdb1. Okay. And where is this sdb1 is getting mounted to? Is getting mounted to, actually delete this here. The good rule of thumb is, if you want to make any entries, the good rule of thumb is copy the existing line, okay? Make that as a good habit. So let's copy this line here on the top, YY, and I'll go down here, and then I'm going to paste this. Okay, so the good habit is do this, and then you edit the line as needed. So I'm going to edit this part here. SDB1, and this one is actually data, and the file system we are using is ext4. So you have to mention the file system which is being used, and the defaults, almost all the time this will stay defaults here, and 0 is, we will talk about this during this here. The 0 is the priority if you want the file system to be checked during the boot process. So we'll come back to this, not now but a little later. So save and exit. Okay, now if I do dff and h, it's already there. I'm sorry, no, it's not there. So now there is a command called mount-a. Mount-a. What this command does is it goes through and reads the file system into the fs tab and reloads the file from there. See, it did that. So if you do dff and h, now our file is mounted here. So earlier you don't see it here, but now you see it here. So the file system is mounted. Now let's go ahead and restart the system and see if it's going to be automatically mounted or not. During the boot process, it will automatically mount. So you do vi etc fs tab, and then so if I log back in again, okay, I can't. I have to go into a new folder. or a session. And if I do dff and h, okay, the file system is mounted here. It may have moved it up and down, but don't worry about that. But you could see the file system is mounted. Earlier when you rebooted, the file system was not mounted, the one we are looking for. Okay, so let me go in here, etcfs tab. So I'm going to copy this. Okay, so what will happen here is this is the mount point. Actually, this is the file system, and this is the data folder. This is the file system, and default is how the OS is going to handle it. Most of the time it's default is default, and this is priority. So this is file system, and this is mount point. Okay, and this is file system type, and operating system handles this, and this is a priority. So you need this piece of information to make an entry in there, okay? So I'm gonna put a note here. Paste into new line and edit as needed. Okay. So now if you mount it, where is this mount -a? So when you run this command mount -a, this command will read okay.
When
So
I run mount -a, it just tells me mount point ext4 does not exist.
yeah, I know why it doesn't exist. Did you copy the existing line before you made an entry? Let's look at your computer. Okay, so what is your ID?
469. 745. 270.
Okay. You might want to update your team viewer. Over here, you should see like a little drop download arrow. Is it updating?
Yep. All right, it's finished now.
Okay.
X2.
I'm sorry, what?
X2 for the password.
X2, okay.
D1.
D as in David 1,
Yes. And then D5.
David 5. Okay. Do you also have a headset?
Yep, made it. Let's try disconnecting and then reconnect.
Okay. What are you trying now?
What happened?
You go. Okay, give me the ID again.
Okay. It is 469.
Yeah, sorry. Give me the password.
All right. WRT
WRT
327.
327. Okay. I think. Why don't you share your screen using WebEx? Did you hear me?
Yes.
Okay.
Okay.
Okay, good. So now Okay, let's go into go into yeah, I can't see your screen now. You there?
Yeah, I'm there. Hold on.
Yeah, share your screen. Okay, yeah, I could see it now. Okay, so were you able to mount it earlier to data folder?
Yeah, I was able to mount it.
Okay, good. So let's go into FS tab, vi/etc/fs tab. Yeah, bring that up. Okay, now make this window, make it bigger. Okay, so what happened is there you need to give the space there also.
Where?
Go down to the last line, and then you see SDB1, right?
Yes.
SDB1, yeah. You're not giving the source. They give some space there, yeah. So that's why the good idea is to copy the existing line from the top, and you never know if there's supposed to be a space or tab. So the good rule of thumb is to copy the existing line. The one I copied is like all the way on the top. Copy that, brought it down, and then change it around. So this looks good here. So save and exit, and mount to into mount -a. Okay,
All
yeah,
right.
it
Sorry.
worked now. So if you do df-h, there you go. That's the data folder right there.
I'm also having the same issue that is also having, I believe, because mine is not running, and I believe I mounted earlier.
Yeah, but you. So I think your team viewer
Me
works,
too.
right? So give me your team viewer.
469-209-539. And the password is EH2V39.
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 Okay, I'm in. Yeah. So make an entry there. Open a new line. Go into new line. Yeah. Give it another space here so that you have good space to work with. Now go back to your other second putty, and you have the information, right?
No,
So
I don't. Let me see.
okay, do this here. Push escape. You are following me just like me, right?
Yes, sir.
Okay, so go to the first line and copy the first line. Scroll up. No. The first line I meant, not the comments. Go down. The first that starts with /dev.
Oh, /dev mapper.
Yeah.
Okay.
Stop there and push YY and then come down all the way on the bottom.
You said push YY?
Yeah.
Okay.
That means you just copied it. Go down, come down all the way down. Then push P as in Papa. Okay, good. You copied the line on the top, okay?
Okay.
Now go into insert mode and delete wherever it's starting from mapper.
So go to, how do you go to the insert mode?
Push I on the keyboard.
Sorry.
And then start deleting it.
From right here?
Yeah.
Okay. So take all these out, take out mapper, centers, roots,
Yeah.
all the way to
Slow. Don't. Man. Do you to undo this, okay? And I've been telling you, you have to have dev everywhere when you're dealing with the hard drives, okay? Now
Okay,
type
sir.
SDB1. And then you created the data folder, right? /data.
Yes, sir. I did earlier. MKDIR data. Okay.
Is it /data or somewhere else?
It was /data.
Okay, good. Now change XFS to ext4. That's it. Escape, save and exit. Shift colon. No. Why are you deleting it? Hold on. Okay, now you have to do shift colon. Oh, yeah, then type X as in Xerox and hit enter. Okay, now do mount -A. Enter. There you go, you didn't get error message. Now type dff-nh. So your data folder is mounted. Now what is the idea behind all this here? When the system is going to reboot, it will automatically mount it and keep it ready for you, okay?
Yes, sir.
All right, good. I think you all are caught up. So let me close this window here. Okay, so so this command will load from etcfs on if it's already not. And also the file system system will be mounted during boot up. Okay, officially it will be this. What surviving a boot is called persistence with the reboot. Okay, so in the interview they will ask you, how do you make the file system persistent with the reboot? The answer is you make an entry into FS tab. Okay, so now what time is it? 3:35. Let's take a break now, okay? Let's take a good 10-minute break and we'll be back in about 10 minutes.
Okay.
And the break starts now. Hopefully everybody's back. So, okay, now what are we going to show you is I'm going to show you we could literally remove unmount the data folder, and then we could mount the file system to any other files, okay? I'm sorry, any other directory. So let's see here. Changing the file system. Okay, so now what will happen is, let's go into the data folder, and if I do ls here, you're gonna find some system generated file here. Remove everything, rm-rf asterisk. So in here what I'm gonna do is I'm gonna create some files here, right? Touch file. I'm going to create 100 files here. Don't worry about the command. We'll talk about this command in scripting. And if I do ls, I have 100 files here. So the files are there, right? But it's not in the data folder. It is actually, the files are being written here. The files, the 100 files I just created is going to be written here. Okay, so how do I explain this? Everybody with me? Can you guys hear me?
Yes, sir.
Okay. So what happened, I created some files just to demonstrate that there are some files on the data folder here, right? But in reality, it is written onto this folder here. The data folder is just like a viewing a window. So what I'm going to do is okay, so I'm gonna go here. I'm gonna clear this. I do df-h. So the data folder is there, right? I'm gonna unmount the data folder. umount slash data and hit enter. If I do dff-h, the data folder is gone. And if I go back into a data folder again, the data folder is not deleted though, it's just unmounted. And if I do ls here, there are no files in there. Okay, so don't panic. That doesn't mean that the data is deleted. Okay, so the files are not there. That means the data folder is not mounted. So what I'm gonna do is I'm gonna get out of here, clear it. I'm gonna create mkdir, and then I'm gonna say a folder name, database. No, I'm gonna name a folder name IBM, and hit enter. Okay, let me go into IBM, cd/IBM. If I do ls, nothing is in there, right? Let me get out of there. What I'm gonna do is I'm gonna mount /dev/sdb1 to IBM. So what do you think happened here? If I go into the folder IBM, look here, SDB1 is now mounted to IBM. So what will happen now? If I go into IBM and I do ls, what should I expect in there? Anybody? cd IBM. If I do ls here, what should I expect?
You're gonna get all the 100 files.
Yes, very good. We'll get all the files here. So for us, the mount point is meaningless. You could mount it to anywhere else, it would still be working. Let's see.
I have a question for you, right quick, sir.
Yeah.
So I changed the directory to IBM and I did ls, but it's telling me R lost and found, lost plus found.
Yeah, there is something. A folder creates that file. You just delete them. I mean, did you create 100 files in there?
Oh no, I didn't create the under file. I think that's yeah.
Okay, run this command. Run this command here with me.
You want me to get out of IBM or?
Oh no! Oh, okay. You are in IBM, right?
Yes, sir. I'm in IBM and I.
Okay, good. Get out of there. And is the data folder still mounted?
Let me
Give me your team viewer. I think this is you, right? 9535.
let me check. I'm 469209539.
Okay, and
EEH
EEH
2 EH V39 EH2 V39.
Okay. Okay, so keep your screen clear here, okay? Because you have so many windows open and everything. It will help you. Yeah, minimize this also. Okay, and this window in the background you barely need it, so just keep it minimized. You need to keep it running though. Okay,
Okay, sir.
so now here, what do you have here? Minimize this. Okay, give me df-h. Okay, so IBM is mounted, right?
Yes, sir.
So go into IBM. Do ls. Okay, let me drive now rm of an rf asterisk. So what I'm gonna do is I'm gonna create 100 files here. So this is the command here, but don't worry about it. 1, 2 periods and 100. If you want to make it 1,000 files, you could do that too. Let's work with 100 files. And if you do ls, you got 100 files in here, right?
Yes, sir.
Now let's go back here. CD. Now go ahead and you mount IBM. You mount IBM. Okay, good. Now go back into IBM again. CD hyphen. Now do ls. The files are gone. Okay, get out of IBM again. Okay, now do dff-h. Okay, now let's do mount -a. Let's mount the data folder. No, the hyphen, not that. A and enter. dff-h. So the data folder is there, right? So go into
Yes,
a
sir.
data folder. CD data. Now if you do ls, what are you going to expect here?
The 100 files to
Yeah,
come up.
very good. See, so what is the story? The logic of the story is the files are, the data is being saved on this location here, not the data folder or IBM or whatever. The not the mount point. The actual data is saved into the file system.
Oh, okay. So basically, no matter what we mount to it, it's still gonna show the 100 files.
Very good. You got it. But at work, don't go and keep changing this around, okay? Because what is happening is application, when they write the application, they're telling the application to go in this folder, so they may have this location in there. If this end up being changed or whatever, then you could troubleshoot it. Okay, so let me get out of here. Okay, everybody caught up? Anybody else need a help? So here,
Could you explain again what mount dash A does again?
it basically what it does is it reads the etcfs tab.
Okay.
Okay? If it's corrupted in etcfs tab, it will give you the error. Okay, now we mounted in so let me get out of here. So if you take a close attention here, pay close attention. This is says UUID. Okay, so now what we're gonna do is we're gonna find the UUID of SDB1, and then we'll mount using UUID. Okay, let's do that. So UUID stands for Universal Unique Identifier. Okay, so how do you find out the UUID of a particular device? Every device has a UUID, okay? I don't care what's on the earth, everything has a UUID, electronic wise. But here I'm only worried about, let's see here if there is a UUID for I'll talk about that later here. But let's talk about the UUID for the hard drive. The hard drive we are working on, we are interested is in dev/sdb1, right? So I want to find out the UUID for dev/sdb1. So the command is, this is a new command, blkid, block ID, and hit enter. So you got this large alphanumeric number here. So all the devices have the UUID on them. So the one we are interested is in dev/sdb1, and this is the UUID it has. And it's kind of telling you the type is ext4 and all that, okay? So I copied this, and then I'm gonna go into I'm gonna edit this into etcfs tab file, okay? So I'll do this. I'll copy this. I'll paste it here. Okay, then what I'll do is I'll do the rest here.
Which one did you copy? Which line?
The same line. Okay. What am I doing here? Okay, some I'll give you a job if somebody explain me what I'm doing here. Okay, explain me this part. So what is happening here is I'm telling it to echo this, but when I use double greater than sign, I'm redirecting it to the etcfs tab here. So when you use two double greater than sign, not two greater than, use greater than sign twice and redirect to the file, what will happen? It will add the line to that etcfs tab. See, there you go. Now what you could do is you could come down here and make this line unreadable. If you put something in front of a line, it becomes unreadable. I'm sorry, not something. If you put a pound sign in front of a line, it becomes a comment actually. So it will be unreadable by the script. I'm going to save and exit. I'm going to umount data folder. I'm going to do df-h. So it's unmounted here, right? Uh-oh, I need to do IBM actually. df-h. So it's gone here. Now let's go into here. So the UUID is the universal ID is for the dev/sdb1 and it's going to mount it to data folder, right? So what happened if I do mount-a? Mount-a is going to mount the data folder. If you do df-h, there you go. SDB1 is mounted to data-h. How is it determining that's SDB1? Because the universal unique identifier gave it the SDB1 a unique ID, and that ID cannot be recreated for any other device in the world. So it will be unique for that specific ID, that specific device. I'm sorry. Okay, so this is a little complicated. You don't have to worry about it, you just have to understand it. So if you issue BLK ID, and this is the identifier, okay? So this part is the identifier, unique identifier. So you copy that and then you put that into the etc folder. So this part here. So you have to commit it out and pound sign, and this part actually I have to get it from the here. Okay, I'm going to stop here. Make sure everybody has a good understanding what is going on. Anybody has questions? Okay, no questions. So then after you do this, you do mount -a. Now, one other thing we could do is we could also give it a name. We could assign this a label too. Okay? Mount using the label. Let's give it a label. So let me clear this. So if you do like BLK ID, here BLK ID here, right? So none of them has a label name to it. So what I'm going to do is I'm going to create a label for the drive. So the command is, it's a new command, E2 label. And then which drive you want to label it, okay? So let me give some space here so that you could see. So the command is E2 label, and you have to pick the drive, which drive you want to use, /dev/sdb1. Okay, and what is the name of the label you want to give it to? You want to give it to ZMPT data. Just give the label ZMPT data like that, uppercase. Or give it a name. Label names, give it name ZMPT01. Okay, and hit enter. Now if you do BLK ID, now the SDB1 should display ZMPT as a label also. Okay, look here. Look here, there is no label in the middle. Now there is a label here after we assign the label. Now what I'm going to do is I'm going to use this to mount. Now I'm going to clear this. So I'll say vi etc fs tab, and then I'm going to copy this line again. Okay, and the previous line I'm going to comment out and then get rid of this line, or no, not line, the information. And then here I'm going to say label, LABEL, it has to be capital letters, equals quote ZMPT01, close the quote, and everything else remain the same, data, ext4 and all that. Okay, okay, so now I see DFF and H. I'm going to do umount /data DFF and H. The data is gone. I'll do mount-a DFF and H, and is mounted just like that, but this time it's using the FS tab using the label. Okay, good. Okay. Now, here's the part here. So let's talk about extending the inodes here, right? Uh, so I'm going to clear this. Okay, I'm going to pause here. Everybody is with me? Anybody has any questions? Borhan, Adil, you good? Okay, so what I'm going to do now is so what I'm going to do is I'm going to fill this data folder so let's create another partition here, okay? Let's do, you could have the multiple partitions here. And then that partition could be any file system. So this partition is 8 gig, 16 is free, right? So what I'm going to do is I'm going to put in some color in here. So what I'm going to do is create a multiple file system. On same disk. So we have SDB1 here, right? So what I'm going to do is SDB1 8 GB, I'm sorry, not SDB1. So 16 out of SDB, 16 is sitting there and getting wasted here, okay? So what I'm going to do is I'm going to create a 4 GB or 2 GB ext file system. Sorry, XFS file system, okay? So it's the same process. So this will be 2 GB and it's going to be dev/sdb2, and then this one has been XFS file system, right? XFS, I'm sorry, ext file system, ext4 file system. So now what I'm going to do is I'm going to make it a XFS file system. So this one is going to be XFS file system, XFS. So the process is same exact process, F disk and all that. So let's start here looking at the F disk command. Type F disk, clear the screen, fdisk / def / sdb. Okay, you don't need to put 1 or 2, just type sdb and hit enter. Okay, and if you need value, type m enter. So let's take a look at the existing partition, p enter. Okay, so existing partition is SDB1. It starts from this block and it's ending at this block, and it has this many blocks. Okay, so let's create a new file system. I'm going to say N for new primary partition, and I want a primary, so P and hit enter. Okay, and then what else I need is partition number. So 1 is not available anymore because the 1 is taken. So you have 2, 3, 4 is available. So number 2 is default. So push 2 and hit enter. And the first sector is starting, the sector is from here, 162792. Okay, where is this number coming from? So it started from here and it's ending here, and then whenever it's end, that's where the starting sector for the another drive. Okay, so yeah, I'm gonna go ahead and select this as a default. This is a starting point. And what is the size I want? The size I want is here 2 GB. So I'm going to say 2 plus 2 uppercase G and hit enter. Okay, so the partition 2 of Linux and of size 2 GB byte is set. I'm going to shoot P and hit enter. That means you could see the partitions. Okay, before that I'm going to write and hit enter. It will quit that. So before that happens, let me capture this. Okay, so I highly recommend you guys go through these commands couple times so that you know what is happening. Partition number 2, enter, and then the size here you just have to hit enter. Okay, use the default value. Okay, and then in this line you're giving 2 GB. You're free to keep whatever you want. I'm using 2 GB here. Let me highlight all this here. Okay, so now here's the partition information. When you hit P and hit enter, it's going to give you the partition information, right? Okay, it's created. Unless you type W and hit enter, it will not write. If you lose the power or anything, you have to go through the process again. Then run part probe. What will happen is part probe will make sure it's written to the kernel operating system. If you do lsblk, so there is a disk 2 here. SDB 2 is there and it's getting wasted. Okay, so I'm going to highlight this. Okay, all right, so now instead of running, remember earlier the command we ran is to create the file system, right? What was the command I used? I used mkfs.ext 4. I use this command here. Okay, so now I'm going to use the little bit different command here to use the XFS file system. So you do lsblk and this is there. So what I'm going to do is I'm going to create a XFS file system. So mkfs.xfs. And which file system I want to do? dev/sdb2. Let me bring this up clear. mkfs.xfs. Okay, then dev/sdb2 and you hit enter and you get a different output here. Okay, the I size is 512, block size is 4096, accounting and all that here. Okay, so I'm not worried about it. I mean, there's a lot of information here, so you don't have to worry about everything in the world. Okay, so I did that, and now I'm going to mount it to a different drive. Data is already taken, so we have IBM there, right? If you go into CD IBM, if I do ls, there's nothing in there because it's not mounted. So I'm going to mount it to the IBM disk now. What is the command? Mount /dev/sdb2 to IBM. df-h. You see now the 2 GB drive is mounted to IBM now. 2 GB partition, I'm sorry. Okay, now, so this is not going to survive the reboot. When I reboot, IBM will not be automatically mounted. So what is the solution?
You have to add it to the F-stack.
Very good. So I go to vi/ectfs tab. Here I'm going to copy this line here because this is more appropriate. Okay, I'm going to copy YY, go down here and paste it in the second line. I mean all the way in the bottom. And then make necessary edits. It's not SDB1, it's SDB2. And it's not data, it's IBM. We are done. Okay? Are we done here or we have something else to do? So we are not done. The biggest thing is the file system. You have to give the good file system here. So if you give ext4, it's not going to work. You have to give just xfs or everything lowercase xfs. Okay, so now okay, I'm going to save and exit. I clear. df-h is there. You mount IBM df-h. IBM is not there. I'm going to say clear the screen. Mount -a df-h. IBM is back. That means it's reading from the FS tab. I'm still not happy, so I'm going to make sure I do the restart. Okay, in the production environment or any computer in the real world scenario, don't just go and reboot the system, okay? You never know what kind of problem you will cause. You have to get a proper authorization before you reboot anything. Okay. Let me do df-h and the system rebooted and IBM is mounted here. Okay. So now let's fill up the drive with some I'm going to clear this. I'm gonna fill the drive with inodes here. Let's see, I'm gonna show you how to extend the inodes here, okay? I never do extending the inodes. It's very risky. Most of the time you just tell the users. Most of the time inodes problem is caused by the files. What kind of files? It will cause by the log files, because log files could be the silly small files and it could take up a lot of inodes. So I have here df-h, right? If you want to see the inodes each drive is providing, df-i. So the inodes IBM could write to is 1 million. Oh my god. The reason why is this 1 million compared to 500,000 here? Anybody could take a wild guess? So SDB2 is XFS file system, and SDB1 is ext file system. So obviously XFS is giving you double as much inodes. So what I'm going to do is I'm going to fill the drive IBM with some garbage files and then see what happens. I'm gonna say touch file 1 2 I haven't done this like create million files at one time, you know what I mean? 110 million followed by 1 2 3 4 5 6. So that's only 110,000, I think. So if I do ls, I have 110,000 files in here, guys. df-h, and see, the file's size is so small, it's only 5% is being used. Okay, so let me try creating a million files. Alright, it's too long, but it must have created something in there. So it's creating 100,000 files at a time. Oh, you know what? What does wc-l does? Yeah, over here, I'm gonna have to change it to something else. Yeah, you have a question? how many files I'm. Okay, we're still stuck at 500,000. I'm gonna see DFF and H. Couple more times. This is just random files. it should crash now. Okay. Maybe this is a good place to show you the errors here. Remember when I was trying to do the catch the errors? You could do 2 greater than and then send it to the file name slash root slash error. Okay, if there is going to be error, all those errors are going to go into that file. Okay. So if you do DFF and H, so the data is only, the use is only 29 megabytes, 29%. But if I do touch file 1, X file, random file, so it says there is no space left. Okay. Why is it? Actually, we are out of time here, so we'll catch up next week right where we left off, and then from there we'll go. Okay, so I'm going to save this and upload it here. And anybody have any questions, put it in a chat and